We're going to do a introduction to JSON in the Oracle database. We have basically 6 objectives that we want to cover in the next 50 minutes or so. And they are, what is JSON? We're going to talk about what JSON is and how you construct a JSON object and so on. We'll talk about how you store JSON in a database and how you update it. And you may be storing it in a database, you may be storing it somewhere else. We're just going to put it in a database for simplicity right now and show you how to update the data. But most of the time is then going to be in the next couple of things, which is a couple of points, which is the 4th objective, consuming JSON data. Once you have JSON data in any format, you need to extract information from it. The whole point is that someone's sending you this JSON data, you have the data, you want to get a piece of it generally, and you need to extract it and consume it and do it efficiently. So we'll be chatting about that. So the 4th bullet is a lot of what we're covering today. In addition, we're going to talk about the next one, which is converting JSON into relational data. If someone gives you JSON and you need to put it into your SQL database, JSON is a hierarchical kind of a structure, not a relational structure. And therefore, you need to convert that hierarchical structure into relational data so that you can do work in the database and put it into the database or whatever. And then the last one, we'll talk briefly about converting relational data to JSON. If you have a whole application with your data and you need to send some of that data to someone else and you guys have agreed to send it as JSON data, which is very likely, then you need to convert your relational data to JSON data, and Oracle supports that as well. Okay, so those are the main goals. First thing, what is JSON? Well, it's a markup language. It's a standard language. It's designed to be simple and universal, meaning everybody could use it. Well, how does everybody use data at the same time? How does everybody use the same data? Well, one of the keys is they use it because they're going to do character data. That's the key here. We want to use character data. Why character data? Because that's pretty much the same in every environment. How people store numeric data is very different. How they store date data is very different. So character data is a simple kind of a technique that everybody understands. Is JSON the only markup language? Of course not. There are plenty of other markup languages. The premier previous markup language that was used before JSON was called XML. Okay, so how is XML different? Well, XML is used and has actually some more capabilities that JSON doesn't have, but those are capabilities that are not really needed in most applications. And as a result, because XML was took longer to process the data and was more complex, it was replaced with JSON. Because there's less storage in JSON than XML, it's faster transmission, less storage required, and because it's less complex, it's faster parsing with less memory overhead. So there's a lot of reasons that things have switched to JSON. Basically, JSON is now the de facto standard for document exchange. And pretty much every language supports JSON. So you've got all of those capabilities there. Okay, we know JSON is text. That's fine. We have some nice capabilities here, and Oracle's implementation, you should know, of JSON started with Oracle 12c, and if you're in 12 or above, you pretty much have enough JSON to really work with. However, Oracle's implementation is a work in progress. It has been significantly enhanced in higher versions. We'll focus on the 12c and we'll discuss the significant enhancements in later versions and where and when you can use it. For instance, 21c, which most people are not on at this point, but that includes, for the first time, a native JSON data type. You know how you create columns, you create variables in PL SQL with a data type. They could be varchar 2, they could be number 52, they can be a date, they can be a timestamp. Well, there is now a JSON data type in 21c. And it has a number of advantages we'll talk about later, but most people are not really using that now because most people are not quite up to 21c yet. Okay, so what's the JSON data format? We talked about JSON. This is, all we're doing is an overview of JSON in Oracle, of course. And there are developers guides in the documentation, full developers guides for every version of Oracle. So you can just go to that and click on the links. Okay, so what's the JSON document format? It stores data as either objects or arrays. There's only 2 different structures, objects and arrays. So we need to learn only two different structures. First one is an object. What does an Oracle object look like? Remember, it's a character string. It's a character string that starts with an open curly brace and ends with a closed curly brace. And it has a collection of name-value pairs separated by commas. So this object has three name-value pairs. Emp ID is the name, the value is 2257. First name is the name, the value is Robert, and so on. And you can have as many of these name-value pairs as you want. Okay? Now, the value can be a string, and notice the strings are in double quotes. The name is always in double quotes. You got a colon, and then if it's a string, it's in double quotes, not single quotes like SQL. Okay? There is if the value happens to be a number, then you can just put a number in. So JSON values that are supported are strings in double quotes, numbers, either integer or floating point, Booleans that are true or false, the keyword null, or here's where all the sophistication comes in. A value in a name value pair can be not just a single value, but it can be an array, a whole bunch of values. Not only can it be a single value or an array, a value can be another object. So in here, as last name, well, last name wouldn't make sense, but let's say I had an address name, then its value could be another object which had several pieces, a street address, a city, a state, a zip, a country, and so on. So by embedding objects and arrays in one another, you can represent any system, any type of data as complex as it might be. So we've talked about the syntax for an object. We've talked now a syntax for an array. An array just has multiple values, but it's the multiple values separated by commas in square brackets. Whenever you have multiple values, you must have an array. By the way, arrays are zero-based in JSON, not one-based like it is in PL SQL or whatever, but zero-based. Now, these values in an array could also be, each one could be an object. Each one could be another array. You can build these things one in another, and that adds tremendous flexibility and capability. So here's an object with an array data. Name value pair, emp ID 2257, first name, last name, but the dependence name is an array, and there are three dependents. And there's your closed brace, and that's a character string. Looking at a couple other complex things you can do, I can have an array containing objects. Here's an array, my open curly brace, closed curly brace, and each one of the elements in the array is an object, and they have a name value pair, color red, comma, value, and so on. Color green, comma, and so on. That's an array containing objects. Here's an object containing other objects and an array. Here's a single object, so my open curly brace, my closed curly brace. It has a name value pair, first name Rick, the next name value pair, last name Jackson, the next one gender male, the next one age 24, but look at address, I mentioned that before. Address can be an object. It can have multiple pieces, so an address has just a curly brace, it's a single object. It doesn't have more than one address, there's only one address in here. So it's an object, street address, colon, 126 Main Street, city and its value, state and its value, postal code and its value, and that object. The next name value pair, phone numbers. Phone numbers, we are allowing each phone number to have two pieces of information, a type and a number. So each phone number is going to be an object. And here's my object, open curly brace, type is home, number and the number. But I'm going to have multiple phone numbers. Therefore, I have a comma and I have the second object. And because there's more than one, I must enclose them in square brackets because it's an array. So you can see you can get fairly sophisticated with this. Okay, well, now that we know how to create JSON objects and JSON arrays and combine them together, we have seen a picture of that. Let's look at storing JSON in the database. We're just going to put it in a database. It could be anywhere. You could be getting it off the internet, whatever. Okay, recall JSON documents are just text. So how are we going to store a JSON document? We're going to store it, be it in PL SQL or in the database in a column or anywhere. We're going to store it as a varchar 2 if it's small. That's max 4K generally, 32K with extended data types. If it's larger, we can put it in a CLOB, character large object. Or you can actually put it in a blob, and believe it or not, Oracle recommends a blob instead of a CLOB. Especially if you have large amounts of data. If you have a small amount of data, it's irrelevant, but with large amounts of data, they recommend a blob because blob saves space, generally about half the space. But because it's more difficult to deal with a blob, why? Because we have character, we have to run a function to convert it from a character, from a clob to a blob. And then on the way into wherever we're sending it, and when we get it out, we have to create it from a blob back into a clob. So we're going to avoid that for simplicity here. We will use in our examples varchar to a clob for simplicity. Okay, now if you are storing this in a database, Oracle has to know that the data is valid JSON and has to validate that the data is valid JSON. If you can't be missing a closed bracket or whatever, it's not going to work. So how do they validate it? There is a new check constraint called Use JSON. We'll see the syntax coming up. And if you have a column that has the Use JSON check constraint and you try to put data into that column, it's going to fail and tell you it's not valid JSON. Just the way if you tried to put in a duplicate primary key or whatever, it would fail and give you an error message. Remember that 21C introduces a JSON data type. So when you get to 21C, that's what you should use for two reasons. One is a simple one. You don't need to use JSON check constraint anymore. But another reason is they've implemented it in a very efficient way. And your DML, your insert, update, delete, and your query you're selecting are a lot more efficient when you use the JSON data type, or when you will be using the JSON data type in the future. But for now, most of us are not working in 21C, so you're going to need the Use JSON constraint. Okay, let's see how we create a table with the JSON clob. We're going to use the Use JSON constraint. We're going to see what happens if we add good data and bad data. And I have some scripts to demonstrate some of this stuff for us. So let's look at that. I'm going to run this in SQL Developer. I have a script called JSON1.SQL. Let's put that in here and run that. And let's take a look at what that the code looks like here. I'm going to create a table with a JSON column. Here's my create table command. Departments JSON is my table name. It's got two columns, department ID, which is your primary key, and department data, which is a clob and is meant to contain my JSON data. I'm putting a not null constraint. That's kind of irrelevant whether we need that or not, but I am putting in a check constraint, and the check constraint syntax is department data, the name of the column, is JSON. And now Oracle will enforce that it's valid JSON. And I'm giving it a constraint name while I'm at it. So if I fail, then all of a sudden I will get a good error message that I violated that constraint name. I inserted data, department data, and department ID and department data. Department ID is 10, and the data is going to have two name value pairs. Department name is administration, comma, and employees is going to be, and in this case, it's just one object. I only have one employee. I could have multiple employees, and when I do, I'm going to need an array, and I could have put this in an array here in case I had more than one employee, but I only had one, so I'm just putting in that one employee now. So this is its own object, and it has employee ID, name, and 200 is the first name value pair, first name and last name. Here's my closed curly brace for that object, and I insert it, I select it, displays it out, no problem. Now let's insert a department 20 that has two employees. So I'm going to have my first one, and what I do is this is my object, and I put a comma and the second object, but this is going to fail, of course. Notice it fails. The check constraint department data must be JSON is violated. Why did it fail? Because if you have more than one, you need to put it in an array. More than one value. We have two values here, separated by commas. It must be in an array. The syntax is invalid JSON. So what do? I just put an open square bracket and a closed square bracket, and it gets inserted fine. I do my select, I get all my data. Okay, so that is our first example. Let's move on here. That was our JSON1.SQL. Now let's look at updating JSON in a database. Unfortunately, before 19C, you must update the entire JSON column. You have to do the entire JSON column. So and JSON is often very big. Arrays can be large arrays. So even if you're updating just one thing, you must update the whole JSON column. And that's a real pain in the neck to do that. But you can attempt to do that and so on. So I'm going to skip this just that example because it's pretty straightforward. We're just updating and we're putting in the whole example, and I want to leave some room for time for questions and things at the end. So updating is kind of difficult. It's not efficient. If you have a huge JSON document and you want to update just one piece of information, one salary, one employee last name or whatever, you got to update the whole thing. So what did Oracle do? Back in 21, they created a JSON merge patch, and that has been successfully backported to 19C at this point. So if you're in 19C at the appropriate release, you can now use merge patch, and it has limited update capability. It allows you to update part of it, but it's not super sophisticated. And why is it not super sophisticated? What's the limitation? Basically, you cannot patch a JSON array, and most of your data is often in JSON arrays. Well, if I can't patch a JSON array, you know, like what's the point? Okay, so JSON merge patch has limited capability for us, and you cannot use specific null values if you have to put nulls into it. The syntax for that is beyond where we're going to go today, but you can look that up. When we get to 21C, there is a JSON transform. Much more sophisticated update. The syntax is more complex, but it supports updating, inserting, deleting any part of JSON data. And you can see the details here. I have heard that there are efforts to backport this to 19. We have not yet successfully seen a backport of that to 19 anywhere. But it's really, really cool, because without that, remember, you have to replace the whole JSON document to change any one part of it. Okay, now let's talk about the guts of this. You need a piece of the JSON document. So you've got this whole JSON document, you got to pull out and select the JSON document. How can you get a piece? Well, we know you can select the entire column and put it in a clob or a bar chart too if it's small, and then you can always parse it manually. You know, use your substring, in-string, all that stuff. Okay, and that actually works with or without the Use JSON column constraint. If it's a character string, as long as you know it's JSON, you can go parse it. You know, too much work, very error prone. We don't want to do that. Therefore, the whole JSON Oracle provides in its support something called dot notation. And you're going to want to use dot notation. And if you can use dot notation, it has some limitations also, which we'll get into. But if you can use it, it's pretty simple. You're going to use dot notation and drill down just the way you typically drill down in all sorts of computer systems for directories or whatever. And you can drill down and find the attributes you want. We'll show you the syntax in a moment. To use dot notation, you must have the is JSON constraint, or Oracle, because Oracle must know it's a valid JSON document. Okay, so without the is JSON constraint, or if Oracle doesn't know it's a valid JSON document, you try to use dot notation, it'll say, hey, I don't understand what you're doing. It's not going to work. When you use dot notation and drill down, you're going to get to a point where you're in arrays. You're going to index into the arrays with the index number, and remember that they're zero based. So let's look at our script here, JSON3.SQL. And I will put this back up, and let's go grab JSON3.SQL and demonstrate how that is done for you.
Remember to enter your questions in the Q&A box.
Okay, great. Okay, I'm rebuilding my table that I had before. Okay, so I have my table with my two rows. I'm going to select my department data, department ID, department data from departments JSON, where department ID equal 20. That gives me the whole document. Okay, the whole document. We want to use dot notation. Okay, so the first time I attempted dot notation, I said, okay, well, the column name is department data. I'm going to use department data dot department name to get it. Well, that doesn't work. Invalid identifier. It doesn't understand that. So I said, all right, well, the documentation says you need to use the table name. So I tried the table name dot department data dot department name, thinking that would work, just saving you some effort, and so you know what not to do. That doesn't work either, because what you have to do is use a alias, a table alias. So if you do d dot department data dot department name, it will drill down and get you the data that you want. Okay, now when you have that, of course, this is standard SQL. You can use your column aliases and everything to change your names and so on. Okay, well, now what we want to do is we want to go down into a JSON data that has arrays in it. Okay, well, I can say d.department data.department name and get that. But if I say d.department data.employees, I will get the employees, but it'll show the array in JSON format. This one, remember, was not an array. This was a simple object, so it shows the object in JSON format. This one had an array. It shows the array in JSON format. But the entire array is displayed. What if we only want one piece of one of the elements in the array? Then we use indexes. So here's what we do. Remember, the first employee is index 0. If I want the first employee, I do d.departmentdata.employees sub 0, square brackets there, dot employee ID, dot first name, dot last name, and sure enough, that works just fine. Okay, but notice this only got the first employee because I had the 0th element. If I want the second employee, I'm going to use index 1. Notice what happens. There is no second employee in Department 10, so it displays nulls. Dot notation always displays nulls if it can't find data. Here, there was a second employee in Department 20. It displays the second employee information. Okay, so the problem is, one of the problems with dot notation is if you're looking and indexing into something or getting a piece that doesn't exist, let's say you were looking for even a name value pair that didn't exist, what's going to happen if you index in? It's just going to return you a null. It's not telling you you have an error. You must have there's an error in there somewhere. You made a mistake. Well, we want to know the difference between a real null and an error, and dot notation won't do that. Dot notation will not allow us to differentiate between a real null and a missing element. Okay, we're going to have a solution for that, but we don't have it yet. The solution is going to be a special function that Oracle provides called the JSON value function. And while we're here, let's look at this. You don't have, if you put in as an index asterisk, that will give you all of them. So I can say I want the employee ID for all of them, all employees. And look what it does. For the one that had only one employee, it gives us the data. But the ones that have more than one that's in an array, the ones that were in an array, if it's in an array, it gives it to you the array in array format, so it has the square brackets. This one didn't do array format because it wasn't an array. Remember, we put it in only as a single object. Okay, so that's dot notation. And if you have dot notation and you're not worried about a missing element and so on, and you can take nulls when it's not there, then dot notation is simple, easy. Use that. You want to use the things that work and that are easy for us. Okay, so let's go back here. That was JSON 3 script. Okay, now we've got a bunch more to come, but before we get into that, back to Dave for a very brief commercial.
Thanks, Jeff. Yeah, I want to let you know we've got a 4-half-day or 2-day JSON class coming up. This in July, on July 18th. It's in half-day sessions. So we think that's a pretty convenient scheduling for many people. Not out of the office for a full day. You're not out of touch with your office. You can do your work on one half of the day and go to class in the other. So there's the class on our website. So you can register on the website, or see at the bottom there, you can simply call in or email Gary, and he'll get you set up with a seat in the class. It's an online class, of course. So we'll supply all the things you need for the workshops as well. And we also provide application development services, primarily Apex. We do some pure PL SQL coding as well, PL SQL applications, but a lot of Apex applications in today's world. And so if you have a need to extend your staff, you're short on a person or two to finish a project, or you need somebody to lead up a project, complete A to Z development, design and development, we can handle that for you. And there's our consulting and application development page off of skillbuilders.com. You can find out all of the things what we have experience with there and see a bunch of the projects we've done. So we do hope you keep us in mind for either training, JSON classes coming up, and or application development requirements that you may want to outsource. We'd love to help you. And that's it, Jeff. Back to you. Thank you very much.
Okay. Thanks, Dave. All right. We were consuming JSON data with dot notation, but we know that there are limits to what the dot notation can do. So the limitations of dot notation is it doesn't allow us to differentiate between a null and a missing element. It must know that it's JSON, so you need the is JSON column constraint. But another way to do it, if you're just getting the data and it's not in the database, you're getting it from somewhere else, you have a special function that was introduced in Oracle 18c that is a treat function, and you can take your JSON character string that you got it from anywhere else. It doesn't know wasn't from the database, doesn't have the is JSON column constraint, and therefore Oracle, to use dot notation, must know it's JSON. So therefore use the treat function, and you can treat it as JSON. So in 18C or later, you can use that function, and now you can use dot notation. So that's pretty cool. Just be careful. The treat function is not validating the data. It's just telling you that your application, in essence, this is valid JSON data, so it better be valid. But if it's not valid when you treat it, and then you use dot notation, it could actually return incorrect data. And make can return nulls when items are missing, can return incorrect data. So be careful with that. Okay, so the takeaway there is that's a nice capability, but make sure you're using it properly and the data is really JSON. Okay, better ways to consume JSON. JSON dot notation we know has limitations, so Oracle provides you with functions: JSON value, JSON query, and JSON table. Those are the three key functions. JSON value drills down and selects a single value, JSON value, a single value anywhere in your JSON document. If you need more than a single value, you need like a piece of this JSON structure, you can use JSON query, and it returns that as a JSON object as a SQL string. So it looks like JSON though. And the third one is JSON table, which is really cool because what it does is it generates an actual virtual table or an inline view, whatever you want to call it, from JSON data. In particular, if you have an arrays. You know, arrays, it's in a single row, but an array has multiple values. And very often you want each of those multiple rows of the array to generate one row of output. Okay, how do we do that? Well, we're going to use JSON table for that. Okay, so that's what we're getting into now. Okay, so we want to retrieve single values. You can retrieve the whole column and parse it again. We know we don't want to do that. You can use dot notation, which I recommend using, as long as the limitations are not a problem for you. If they are a problem for you, you're going to use JSON value. Okay, JSON value is a function. You do the function on the JSON column name or on the JSON string, and you have to have a valid JSON path expression. The first column in the first argument to the JSON value is the column name or the JSON data itself, and the second argument is a valid JSON path expression. So path expression is a character string, starts with a $, and basically uses pretty much dot notation to drill down to get the scalar you want. But this dot notation works a lot better than the pure dot notation because it's in a JSON value function and Oracle controls what it does. So JSON, yes.
Can the JSON value function get a blob?
Nope, the JSON value must return a single value, a string, a number, a date, or whatever. If you try to return anything more than that, it will give you an error. So right here, you led me right into it. It raises an error if a non-scalar is returned. If you want more than that, if you want more of the data, then you need to use one of the other function that we just talked about here, which is your JSON query. That can return any part of the JSON argument, but as character, not as blob. You have to always, anything we're doing has to be with characters, so you have to convert from blob back to character first. Okay. All right. So JSON value returns a null if no value is found. We know that. Okay, well, we know that the dot notation always returns a null, but JSON value also returns a null if no value is found. Well, Jeff, you know, what's the advantage? It's not giving us anything. It's the same problem that dot notation had. Well, not quite. It's returning a null, but it's really not returning a null. It's really returning an error, but the error defaults to null on error. That can drive you crazy when you're first learning it, where you try it out and you know it's supposed to work, but it doesn't. But null on error is the default. So how can you override that? There's an option in the JSON value function to say error on error. There's another clause. Now, if it can't find it, if it's not there or whatever, if you have error on error, it will not return a null. It'll actually return the error so you can identify it. Okay, and there's a script here, JSON6.SQL. Let's take a quick look at that. Let me grab that script. And we'll run that. Okay, by the way, all these scripts will be available to you when we finish putting everything from the webinar here online. Okay, here I am selecting, this is using dot notation. We've learned that before. Employee sub 0 worked fine, gave me Jennifer. Okay. I can do the exact same thing as I did with dot notation with the JSON value function. Here's how I do it. JSON value, I say what column is it in? It's in the department data column, or I had the whole variable in there or whatever when I'm using it and it's not in a column. And then I have my JSON path expression. It starts with a $sign dot, it's a character string, and then it drills down. It's the same drill down. Gives me Jennifer. Okay. Notice if I ask to index 1 and I use my dot notation, it's going to return a null, and there's no way to get around that. Okay. Here, there's no second employee in department 10. No value is found. Oracle returns a null. So this was dot notation. If you try the error on error technique with dot notation, that doesn't work because the error on error technique doesn't apply to dot notation. It only applies to the JSON value function. So here's my JSON value function. And because I did not have the error on error, it defaults to null on error. And therefore, it returns a null the same way that regular dot notation did. But if I add in the error on error clause to my JSON value, then it returns the error that I expected. JSON value evaluated to no value. There was no second employee in department ID 10. So that solved that problem for us. Okay. There is a second employee in department 20. So if I look for that, I get my second employee. So that works just fine. Okay, let's go back to our presentation again here. That was JSON3.SQL. I'm sorry, that was our path expression, JSON6.SQL. Now let's look at JSON query. JSON value retrieved a single scalar value. If you want a string back with part of the JSON document, if you want a whole string, then you're going to use JSON query instead of JSON value. JSON query is similar to JSON value. It takes the JSON column name as its first argument, a path expression with the $sign and so on as a second argument, but you need a little bit extra. You need a returning clause in the path expression. And you have to say what the data type is you're returning. Returning varchar2, unfortunately, is the only valid return type in Oracle 12, but when you're up to 18, you can return it in a clob, which is a larger value, or a blob, either way. Okay, so that can fix that. So that's one of the differences that JSON query has. Make sure you add a returning clause, returning varchar2, returning blob or clob. Additionally, the second thing you have to remember in the JSON query clause is that if you return more than one object, it's going to give you an error, unless you put in another clause with wrapper. So you need another clause, and as well as the clause that gives it the return data type, you need a clause that says with wrapper or pretty with wrapper. With wrapper is just basically one long string. For the JSON data, it prettifies it, and it gives it indented and so on, and it looks like nice JSON format. Okay. As with the JSON value, it has the error on error clause if you want to detect things that are missing. Okay. And it returns the string in JSON format. So now this is JSON query, so it's not returning just a scalar, it returns a string in JSON format. If it happens to be an array, it returns it in square brackets. If it's an object, curly braces, and so on. Okay, we did JSON value, JSON query. What if we want to project our data as rows and columns? JSON data is hierarchical. We need to change that structure to rows and columns. Well, why would we want to do that? Well, we may want to display data as in a standard column in the report. We may want to take that hierarchical, that data that is in a hierarchical format in JSON and convert it to a relational format and put it into a table as rows and columns. As a matter of fact, you can even create a relational view from the JSON data. Well, when you create a relational view from a JSON data and give someone that view, that's great, because if they don't know any JSON, all they know is their SQL, they can use standard SQL to go get any of the data out of the JSON data. Okay, so there's a lot of reasons, and once you convert it to standard SQL format, you can do all your normal selects and joins and everything else that you want to do with as if it were SQL data, standard relational data. Okay, now for simple JSON documents with no arrays, okay, you want to convert that to relational data. Nope, it's really not a problem. Use JSON value. for each piece you want, and it gives, and you have multiple JSON values, what dot notation or whatever you want to use, and you get all your columns and you convert it to relational data. That's fine. Well, that's the simple case when there's no arrays. But when your data gets more complex and you have arrays, there's a problem. In our examples, remember, we had each department, but it could have multiple arrays. And all we could do so far was display that as JSON data. But what we really want to do is take any general information like the department ID and the department name and have those as columns. But now we want to have the name, all the information about the first employee. Then we want to repeat the department ID and the department name and have the information for the second, and repeat it again and have it for the third, and so on for as many rows as we have in an array. Okay, so how do we do that? We use the JSON table function. The concept's a little tricky, but it's certainly worth going through. The JSON table function creates a table, and here's the key, with one row for each value in a JSON array. So it's got a table, and it has one row for every one of the values in a JSON array. Okay, so now we use the JSON table function, and we create that table from each array. And now we list in that table that we created with the JSON table, we put that in our from clause, and we put the main table that had the JSON column or whatever in the from clause. So now in our from clause, we have two tables. One's the main table, and one is a table that's created just from each individual array on each row. And Oracle will see those two tables and do an implicit join of those two tables. So it'll take the columns that are in the first row and join it in the first row of the main table and join it with every row from the array. And then this columns values that are in the second row of the main table and join it with every row in the array for that second row, and so on, and create relational data out of it. Really cool stuff. Let's take a look at how that's done. We need to know the syntax for the JSON table, you need the JSON column name as arguments. And now the second argument is a little more sophisticated. You need a list of all the high-level attributes, the ones that are not in the array. And then we need a special syntax, a nested path that picks out any of the columns in the array that you want in that relational view. You could pick all the columns, or you could pick and choose the ones you want. And you can use standard JSON path expressions followed by an optional error clause within this. Okay, so you can have an error clause as well. Let's look at JSON 8 and JSON 9 and kind of finish up with this main concept. So I'm going to pull out my JSON 8 script and then my JSON 9 script. Okay, I didn't show you an example of JSON query, so let's just take a quick look at that. Here's my department ID, department data.department name using standard dot notation. And now I'm going to use JSON query that says go to the department data and get me all the employees. $, employees sub star. And remember, we need a returning clause, returning varchar 2. And we need a wrapper with wrapper or pretty with wrapper. So I'm adding those in. We need that information. And that will show us all the employees. The first department 10 had only one employee. The second one had 2 employees. So we have only 2 rows, but we have 3 employees. What do we really want? We really want 10 admin, 200 Jennifer Whalen, 20 marketing, 201 Michael Hartstein, and 20 marketing, 202 Pat Fab. That's what we really want. Okay, how do we get that? Well, we're going to look at the JSON table function. So we're going to select our department ID, and we're going to use the JSON table function on the department data. Okay, and here's the syntax. I told you it's a little bit more complex than just the dot notation. We start with the $, and now we say what columns do we want in that table? Well, we want the department name. That's a high-level column. But the employees is an array, so you have to say nested employees. I'm selecting all of the rows. I could select just some of the rows, but I'm selecting them all. And I'm selecting all the columns, but I could pick and choose my columns. So JSON table is going to give me a table with the first column department name, second column employee ID, third column first name, fourth column last name. And that's the JSON table. But I have my from clause, and I'm joining basically the department's JSON table with this table, and it does it once for each row in the department's JSON table. Remember I said it does an implicit join of the first row with every row that JSON table produces for the first row. Then it gets the second row from department's JSON and creates another table from that array of all of the rows in that array. And look what we get. 1, 10, 200 Jennifer Whalen, 20, 201 Michael Hartstein, 20, 202 Pat Babb. We get our 3 rows, which is really cool. We get relational data. And just to emphasize how nice that relational data is, I will take a second here and display it to you with the run command instead of the other way, instead of the script output. Okay, so that was JSON 8, and let's do one more thing. I'm going to get JSON 9 just to show how we can get even more, do even cooler things. I'm going to get JSON 9, run this, and here all we're doing is creating a relational view, department's relational as that select statement. I didn't point out before that I had named that table J. I probably should have pointed that out, and that's why I had J.department name, J.employee ID, and so on. So I create a relational view, and I select star from the relational view. If I select star from my original table, I only have 2 rows. I select star from my relational view of that, I get 3 rows, and anyone can use this relational view if you give that to them, and they can do anything with it, join it to other tables, you know, the whole works. So that's really very cool. Okay. Which brings us to, we did scripts JSON 8 and 9. You should know, you might be thinking, well, this is really nice, but what if I have a lot of JSON data, many rows and arrays, you know, searching that array, how am I going to do that efficiently? Well, to searching, Oracle provides indexes on JSON data. You can actually create JSON indexes on the JSON data. And when you do that, you create an index and it works very efficiently. It'll go into the arrays and do every row on the array and create indexes on the arrays as well. So you don't have to read a whole array out and search it yourself or whatever for any value you're looking for. So that is a pretty cool capability. So not only can we use this stuff, but we can use it pretty efficiently. One last thing, how do you create JSON data from relational data? I'm not going to spend too much time on that because we're running short on time, but basically Oracle provides 4 functions, JSON object, object aggregate, array, and array aggregate. And with those 4 functions, the neat thing about those 4 functions is they guarantee to generate proper JSON. You can do it yourself programmatically, but you better be careful. You miss one closed curly brace or anything, and you got bad JSON. This guarantees that it's good JSON. So that's the neat part. And last but not least, besides in SQL, Oracle has enhanced PL/SQL and given us a whole bunch of new PL/SQL data types to work with JSON in PL/SQL, and Apex supports JSON and you, of course, because you have PL/SQL, you can use that in Apex. Apex for a long time has a Apex JSON package that has a number of functions in there that make using Apex in JSON a lot more easier than trying to code it all yourself. So those are topics for another class or whatever. Just a summary, Oracle provides basic JSON support starting in 12.2, improve with each version. 21C, switch to the JSON data type if you have it. And most of those new features are enhanced data manipulation and better processing efficiency. Cool. Okay, Dave, back to you.
Thanks, Jeff. Yeah, so what's next for learning? The class is coming up, the Introduction to JSON in Oracle Databases. We mentioned that's coming up in July. So one thing I didn't mention before, there's 5 reviews on the website from the students that took the first and last offering of the class. We'd like you to check those out. So you'll see that students were very happy with that class. But another class that we're likely to develop is REST services in JSON in Apex. So the length of this class is still to be determined, but stay tuned. If we develop the class, get it ready, we will send you an email. By the way, I just put in the chat the link to the Introduction to JSON in Oracle Databases class. That link is now in your chat. And if you have any final questions, please chat them in now. Thank you very much for attending today's session. Keep us in mind, not only for the training, but for any Apex application development needs that you may have. One service that we found very useful and very popular for our customers is design reviews. Are you building your Apex, for people who are new to Apex, are you designing your application with best practices in mind? So before you bake in all the design elements that you have created, you might want us to take a look at the design and see if it's got the best practices in mind. You can email Gary to register for any class, or you can register online. You can call us at the phone number shown there, put a +1 in front of it, and you'll get us from outside the country. We are in Rhode Island, USA. And that's about it. I don't see any further questions. So stay tuned. More JSON and Oracle coming up. Class on July 18th, 4 half-day sessions, and the REST services and JSON in Apex class under development. Thanks very much for coming, everybody. Appreciate your time. Appreciate your listening.